Good afternoon, everyone. Thank you for joining us for another session of the NBS Distinguished Speaker Series, which is a part of NBS effort to promote interdisciplinary discussions that will lead to new research and new educational opportunities. So today's topic is on robots. So glad to know that I heard that today's session has attracted more than 200 registrants from 18 countries and 25 industries. So quite impressive. So at the start, as we did in the past, I would like to conduct a poll with just 2 questions. You should be able to see the first question now. So both questions actually are very easy ones and open-ended questions that don't really have a right or wrong answer. So take it easy. So the purpose is just to really get an idea of our audience perception about robots in general. And you have about 30 seconds to answer the question. So the first one is, when will door-to-door robot delivery services that cover nearly all of Singapore be available? In 3 years, 5 years, 10 years, or never? Okay. And then the second question is, we should show the second question. Okay. Would you prefer to be served by a robot receptionist or human receptionist? Okay, you choose between these 2 choices. Okay, so briefly introducing myself first, I'm Xin Chang from NBS. I like people call me Simba. I'm a professor of finance at NBS. I'm also the associate dean for research in the business school. I'm one of the 2 moderators today. The other moderator is my colleague at NBS, Professor Sharon Ng. Sharon is a professor of marketing and also the head of our marketing division at Nanyang Business School. She got her PhD from University of Minnesota. She has published many papers in the top marketing journals. She's also currently sitting on the editorial board of Journal of Consumer Research, one of the best business and marketing journals. She is a real expert on branding and strategic branding management. Recently, she has been doing research about robot and human collaborations. So at the end of this session, she will give a concluding remark as well. And then let me introduce our speaker today, Professor David Hsu. David is a Provost Chair Professor in the Department of Computer Science at NUS. He's also a founding director of NUS Artificial Intelligence Laboratory and the director of Smart Systems Institute. He got his PhD from Stanford University in computer science, and he's also a IEEE fellow. His research is mainly about robotics, AI, and computational biology. He's an expert on robust robot decision-making under uncertainty and human-robot collaborations. He has won many international awards for his research on these topics. So we're really lucky today to have him speak about living with robots. His talk will last about 50 minutes, followed by the Q&A session. So I strongly encourage all the audience to ask questions using the Q&A function. Okay, and just type your question into the box. I guess we can see the poll results if we can now. For the first question, we have about 45% of people believe that we can achieve door-to-door robot delivery in the next 3 years. Okay, 27% believe it will happen, 5 years, but we have 4% people believe it will never happen. Okay. For the second question, about your preferences in the restaurant, for example, or in a service. If are you willing to be served by a robot receptionist or human? We have 80%, roughly 80% of people still prefer to be served by a human receptionist. Only 21% is okay with a robot receptionist. So let's see whether your perceptions will be affected by Professor Hsu's talk. So over to you, David. You have 50 minutes.
Yeah. All right. Well, thank you, Simba and Sharon, for the invitation. And it's delighted to be here and speak to all of you. It's a wonderful opportunity. I want to tell you about the robots today, mainly about three things, and to share with you some of the excitement of in the robotics world in terms of technological developments. Robots are cool. And because of that, sometimes we have unrealistic expectation of robots because we watch too many movies, and that's not good. And especially, it's a bad idea to use that as a basis for important decisions. And finally, let's try to look into the future and put our minds together and think about what's to come. Okay. I want to start by telling you why I'm so in love with robots. Right. So these days we all carry mobile phones around, and anytime we need help with the weather or calendar events or find something to eat, we just ask our mobile phone, right? Hey Google, hey Siri, and the help comes. But there's another set of important things in life that Google cannot help with. Can you open the windows? And can you pass me over item in the fridge? Or can you make tea? Anything that requires physical actions, Google cannot help with. And that tend to be the kind of things that I hear from my wife during the weekend. And since Google cannot help, so hey Google becomes hey David. Right? But I'm an engineer. What I want to do is to build a robot helper to answer to my wife's calls, so that hey David becomes hey robot, right? Now, to build such a robot helper, the robot must have a basic set of capabilities, mobility, to be able to move around, and the manipulation, and to use the hands to interact with a variety of common daily objects in our household. So let me start by telling you some of the things that we are doing here in our NUS laboratories. So to be able to move around, we acquired this legged robot, which we can purchase. But the legged robot itself can move around under teleoperation that a human must directly use joysticks to operate these robots. So what we did is to put on top of that a sensor package, and mainly the cameras, sometimes the GPS units as well, so that the robot will be able to see and be aware of the environment around. And more importantly, this rectangular box behind, which you can see that the process the sensor input, which will be able to connect what the robot sees and the command on robot where to go next. Right? With such a system, we hope that our robot eventually will go to anywhere on NUS campus, and maybe even in the future, they can go anywhere in Singapore as well. Now, let me show you what our robot is capable of today. This is the NUS campus, Kent Ridge campus, right behind our building on the Kent Ridge. Right. There's human blocking the way. It's going to stop. See enter our building in a semi-over navigating an obstacle. Oops, there is an expected obstruction like this chair. The robot stops as a door into a glass door. The door opens, the robot realizes Forward, staircases. Right to people, right to way. And you can see that our robots can operate in a wide variety of different environments, different kind of ground surfaces. Some of them are tiled, some of them are carpeted, some are paved, right? It can also handle different lighting conditions, dark and light, and it goes navigates on flat surfaces, go upstairs and downstairs, so on and so forth. So it can handle enormous amount of variability that is significant change in the operating conditions. Variability is very important for robot performance. Another thing important for humans is a sense of touch. Right? So a human has a very delicate sense of touch. In fact, that's a precondition for our agility in handling a wide variety of different objects. So at the NUS, my colleagues and Benjamin T and Harold So, they are developing new materials and sensors in order to give our robots a high resolution, very accurate sense of touch, and they call it NUS AI skin. Now, when we put this AI skin on the fingertip of our robots, and let's see what our robot can do. It's going to pick up a piece of tofu. Right. For any of us who have tried to pick up a tofu, we understand the importance of that sense of touch. Without it, we would not be able to put right amount of pressure, and the tofu might fall, or if we put too much pressure and the tofu gets squashed and becomes soy milk. Now, beyond the NUS, in the greater robotics research community and the robotics industry, the wide variety of different industry, there are interesting robots. And let me start with one that you are probably familiar with. These industrial robots that line up on the assembly lines, they are very fast, they are reliable, they are very powerful, and they work there tirelessly. And because of them, we have cars and other manufacturing goods at the moderate prices. But they are kind of dull, right? In recent years, we have a lot more interesting robots. This one, called Big Dog, coming also from Boston Dynamics. You can think of that as a bigger and more capable cousin of the Spot robot that I showed you earlier. It can navigate very difficult terrains. It has amazing ability to balance itself dynamically and sustain the disturbance, this powerful kick sidewise. Most of us, if we get this, we probably would have to fall. It can even balance itself on a sheet of ice. Extremely challenging. Look at the first steps to regain the balance. Sometimes robots take unusual forms, and this is Amazon's e-commerce warehouse. Each of the shelf over there, in fact, is a robot. To be precise, the shelf itself is actually stationary, but a base robot platform engages with the shelf and kind of carries it around. It carries the ordered goods to a packing station, where a human packer will pick up the items and put it off for shipping. Now, by doing this, the human packer can stay stationary, and the shelves move around and to send the items to the packing station. This reduces the total amount of distance the human packer have to travel, and increases vastly the efficiency of the warehouse. So the last one I want to show you is the surgical robots. It's a Da Vinci surgical robot system. This is just performing a demo here. instead of suturing together the human skin, he's trying to put together the skin of a piece of plate. Okay, that is allocated on humans. Now let's try to tie a knot. This is just amazing, right? What robots can do. The excitement of robots goes beyond a particular system or even a company. It's actually entire new rising industry, right? Autonomous driving. Here you can see the traditional players in this industry, the car manufacturers, the GM, BMWs, and Volvos. You can see the internet titans, the Google and the Baidu. You can see the technology disruptors, Tesla and Uber. You can see all sorts of startup companies, Pony AI, Drive.ai, AutoX AI. You also see the unexpected players like Panasonic, because Panasonic is an OEM supplier for many of the Japanese car companies. All these companies are working on autonomous driving. It's a new industry. And now, beyond autonomous driving, there are a lot of excitement in other parts of robotics as well. I picked up an industry newsletter. You can see over here investment in robot startups, in manufacturing, in agriculture, in cleaning services. And of course, there's always a lot of interest in autonomous driving. The companies are also building collaborative robots to work with people together. They are called cobots. Now, if you put together the numbers on this slide, it adds up to $1.1 billion. And that is only an incomplete compilation from a particular industry letter for the month of November. That is this month. Singapore, being a technologically advanced nation, has a piece of action as well. And about 10 years ago, NUS and MIT together collaborated at the Singapore MIT Alliance program and built the Singapore's very first self-driving car. And that's the base technology that eventually led to the launch of autonomy, and that was later acquired. And there are a lot more startup robotic companies in Singapore. If you go visit Block 71 or NTU's Tech Park. And also that NTU has a huge robotics center, and for the NTU students, faculty, as well as alumni, if you want to see with your own eyes, firsthand interesting robots, and that's definitely an interesting place to visit. Okay. Now, with all this excitement, I think it's easy to get carried away and still think about those robots we see in the movies. That would be wrong. Maybe that can be my first message to you. Most of the things you see about the robots in the movies are wrong, and we do not want to use that as our basis for decisions. Now, to keep us sober, and I would like to show you a couple of examples of not so great technology, not so great robotic technology. Okay. So this is the humanoid robot. It is trying to open this door. All right, this happens maybe because that the robot tries to push forward the door and loses balance. All right. Well, this may be that it fails to detect that the door is already open and try to push forward, and therefore it loses balance. How about this one? It's beyond me. I don't understand what happened over here. Now, if you think that this is sloppy technology, definitely that it is not. All right, so this is a DARPA Robotics Challenge in year 2015, and they gathered some of the most advanced robots and some of the most capable robotics researchers and engineers over there. And that, in some sense, is a state of the art that failed. Well, sometimes technology is no problem. right? And around this, also 6 years ago, and the BBC reported drone waiters to plug Singapore's service star gap. That is, we do not have enough waiters and waitresses, so we want to these flying drones and to serve food and drinks in our restaurants. We love flying drones as a cool technology. We would like drones to deliver goods, perform delivering services. But do we really want drones to deliver food and drinks in our restaurants? How about that noise that it generates in the restaurant? How about safety? And how long that the battery of drone can last? How many customers can it serve before it runs out of battery? In fact, I wonder, other than the BBC interviewer, how many customers this drone has ever served? Right? So there's nothing wrong here. There's nothing wrong with technology per se, but it's a misuse or misdeployment of the technology. Right? And today, if you try to find this restaurant or find the drone that delivers food and drinks to serve in the restaurant, I'm pretty sure that you won't be able to find it today. Now, it seems that it's a paradoxical here. On one hand, we have these amazing robots that can perform surgery. On the other hand, this state-of-the-art robot cannot even open a door. So what's going on over here? The answer partly lies in robot demos. Right? I'm borrowing this phrase from this saying from statistics to highlight this issue with robot demos. Robot demo, especially a robot demo video, what it can show you is the performance of the robot in a particular robot operating condition, right? And it may or may not be representative. But the overall success of a robot system depends on the variability of the operating environment and how well the robot can handle all these variabilities. And therefore, that if we just watch a robot, particular robot demo, especially if it's a video, and believing our eyes, what we see, without context, without technological background, and that's going to be very dangerous, right? So it's, again, I want to emphasize the ability to handle variability determines the overall chance of success of a robot system. Now, on the left, if you look at the surgical system, despite that it is very complex and requires very sophisticated actions, in fact, the variability is quite limited. Surgical operating theaters are tightly controlled, and the patient is under general anesthesia and hardly moves at all. But more than that, Da Vinci system is teleoperated by a professional, a surgeon, and any residual variability will be handled not by the robot system, but by the human. And in contrast, that the robot system, this autonomous humanoid robots, had to open a wide variety of doors. Now, on your way back home from the office today, maybe you want to take notice the different kind of doors you have to go through. Most of them are hinged, but some are sliding doors. Some of them are even folding doors. And also take notice of the different kind of handles that we have on our doors. That some of them have vertical bars, horizontal bars. Others have handles, knobs, and all this variety. And our autonomous robots must take care of all of them. And that's a variability that causes the failure of our autonomous robots. So, so oftentimes that we underestimate the importance of variability and adaptivity, and overestimate the importance of speed and strength and the precision of a robot system. And this bias is there for a reason. And if you think about we ourselves as humans compared with our animal peers, we are not very fast, not very powerful, and not even very precise. And now, on the other hand, we are highly adaptable. And it's probably for this reason, we survived hundreds of thousands of years and almost climbed to the top of the animal kingdom, right? So those things we have, adaptivity, ability to handle variability, we don't care about very much. We care about those things that we don't have, right? But if we carry this bias when we evaluate the performance of robot system, that is a danger here. It is important to keep that one in mind. Variability, adaptivity is extremely important for success of robot system. Now, going forward, there are a few trends that's very important in the robotic industry. The first and foremost, the most important one is aging. And the world is just getting old everywhere, with almost no exception. Now, Singapore is a little bit too small to notice on this picture over here, but our problem is just as urgent, if not urgent. According to this article over here, that by year 2050, about half of the Singaporeans will be over the age of 60, right? And if you check against the scale or the color coding of the picture, they are measuring people over 30%, and old people, the maximum over there is 30%. For Singapore, we are beyond scale. So we have an urgent need over here. Now, robots can help, but this is well known, right? So the one of the main problem with aging and the immediate consequence is well known, right? So fewer workers and more elderly people to care for. In fact, this second one has an indirect consequence, which is that the young people have to take care of the old people, and then reduces their availability for other work. Robots can indeed help, and this has been practiced already for decades. We can use robots to reduce human labor and increase productivity. And for certain kind of work environment, it's actually dangerous for human to be in, and it's great to put robots there instead. Now, there's a side effect of doing this. What are we going to do with people, the workers who are displaced by the robot workers? This issue is usually not as much a problem in Singapore, but in most of the other parts of the development world, in the Western world, that is a real major issue, and it's actually very important. And we must handle that in order to guarantee the long-term survival and the thriving of robotics industry. Now, instead of replace, so this is a complex issue. There are many dimensions to the solution now from a robot technological point of standpoint. So what we can do is to get robots to work with humans together. So instead of replace the workers, we can have the robots to work with the humans together. So instead of, so we can have so to see complementarity between the capabilities of human workers and robots, right? So to use robots to expand human capabilities instead of using robots to replace human workers. Right? And another thing that the robot can help with are the robot helpers, right? My Hey robot. Robots can help provide better care, assistance to elderly people living at home, and to prolong the duration of their independent living and improving their quality of life, and to lead a more meaningful and fulfilling life in their senior ages. So what we want is a new generation of robot technology that would enable the robots to interact and collaborate with their humans seamlessly. But this new robotics is in fact very different from the old robotics. Now, in the old robotics, you can see that from the picture over here, there's no human over there. We focus on autonomy. Autonomy is an end goal in itself. We get rid of the humans, and we want the robots to be fast and accurate. To achieve that, we make robots we give robots very rigid structures and power them using very powerful motors and make them very fast, at the same time, very dangerous. Now, in the future, we want robots to work at the homes and in offices and in close proximity with humans. Now, for that, in our home environments, robots must handle a wide variety of different situations. We want the robots to be aware and be able to adapt to all this variety and to cater to the human needs and preferences. So how do we achieve that then? Maybe we can look back into the history of robot technology and find some hints. More than half a century ago, right? So manufacturing industry is among the first to adopt the robot technology. And the idea over there, in order to deploy robots successfully, and the strategy is to remove the humans, right? So in fact, those robots are so powerful and dangerous, so powerful and dangerous that we must keep humans away. Now, once we remove the humans, we also remove a significant source of variability, and on the assembly lines, the parts will come in and they're in the right place, right time, and the robots just need to act on that as fast as possible. Okay. Now, forward 20 years at around the turn of the millennium, and that's the era that starts the era of autonomous driving, self-driving cars, right? And there we cannot really remove humans, and the cars will be on the road, and it will have to interact with humans and the cars driven by other humans. But the very nature of the driving task itself says that really that what we need to do is to keep our robot vehicle a safe distance from pedestrians and other human-driven cars, right? So we could call that the robotic technology to avoid humans. Fast forward another 20 years, it's about the time now, right? So we want to use, we need robots to help us in maybe hospitals, provide hospital services, and sometimes maybe even rehabilitations. Here, robot gets a bit closer, even closer to humans, especially for rehabilitation, for example. It directly comes into contact with humans. But hospital is an interesting environment, right? And it has most of the basic elements of life, but it's also at the same time, it's a semi-controlled, right? So as patients, when we visit the hospitals, we happily follow instructions from doctors and nurses. We are willingly give up some of our so-called freedom in order to receive the proper medical care, right? So the variability can be controlled to an extent. Now, if we look forward another 10 years and or even further into the future, maybe we want to put robots in hotels and restaurants and offices and homes. And there, it is not possible to control the environments over there. And human will make a wide variety of different requests, and the robots will come into very close proximity with humans in order to perform those services. And we need the robots to understand human intentions and the preferences in order to perform those services as well. So it seems that the old strategy don't quite work for the future, and we do need the robots to connect with humans much more closely. Now, to do that, we almost have to rebuild a new technology stack and connects humans and robots at the multiple levels. Okay. At the lowest level, we need to build the robots using new materials. Why? For safety. right? So the old robotics, which is very rigid, very stiff, and very strong. If human ever comes into contact with those robots, injury, that's the minimum. Death is a possibility. Now, if you compare that with the materials and the structure that form the human body, it's very different, right? So humans have a muscular skeleton system and are covered by skin, right? So even if that we come into contact with another human, there's only limited damage. So we want to build the robots using soft materials, using the soft materials to build the robot sensors and actuators, so that even in the worst case, the contact actually occurs and the damage and the injury is contained. We need a new magnetronic controllers that be able to actively sense impact and contact and respond to them appropriately. How would we like to command our robots? We could say that maybe for some of us, we could say that the nerds, right? So we can program the robots. That's definitely a possibility, and that's what we do in our labs. But if we want to deploy robots in our household, let's say in our kitchens, well, in the kitchen, do we program our fridge? Do we program our microwave oven? Do we, right? We don't program any of those things. So why should we program our robots? We should be able to instruct our robots in a natural modality of interaction, speech, human language. That's what we usually do, right, with human helpers. We should be able to do the same with robots. So the robots must understand human speech. But human speech also have limitations. Sometimes it's vague, right? And therefore, we need additional modalities of interactions, and that need to design new interfaces is to make robots easy to use. And above all, we need the robots to be intelligent. This is the age of AI. Then this exponential growth of AI technology enables our robots to reason about human intentions, preferences, and even to elicit trust from humans in the robots. Right? And also that machine learning technology enables the robots to learn to improve its performance through interaction with the humans. And also that the communication technology that would enable us to link together humans and robots. In fact, large teams of the humans and robots together enable them to work together to solve complex tasks. Now, in this here, that when we robots and humans that form a large teams together, then that comes to the issue is, how do we form such teams? How do the team members communicate with each other? How do they communicate their goals and the plans in order to coordinate, right? So it is in this place, I think, that the study of robots will intersect significantly with the study of the humans. And many of the issues that are studied in humanities and in business schools, how we form teams to study of human behaviors, will become important for the future of robotics. Another significant trend that we must take note is China. About 20 years ago, I mean, year 2002 or 3. So I looked at China and decided, what I do has nothing to do with China. I mean, robots have nothing to do with China. According to this chart, you can see that I'm quite right about that. This chart shows the number of operational industrial robots in each of these 5 countries over there in year 2002 and 3, and the number of robots in China is near 0, totally irrelevant. And 10 years later, about 2011 or maybe 12 or something like that. We want to buy a new robot. That's a KUKA robot. KUKA is the latest cobot. So the collaborative robots that work with humans. KUKA is Germany's most advanced robotics company. We want to buy this robot, but back then, KUKA didn't even sell this robot in the Asian market at all. So I was talking to the KUKA executives and try to convince them to sell us that robots. I did succeed in that. We got 2 KUKA robots, but the KUKA executives, all they want to talk about, in fact, is all about China. So the Chinese market is rising, and it's going to be the future of robots, and it's very important for KUKA and so on and so forth. Because that meant he thought he was talking to an Asian customers, and he was trying to get more information about Singapore and China. Now, if you look at the deployed industrial robots around that time, indeed, the number of robots is already rising in China, but if you look at the overall trend, it's still, the ordering roughly is the same, right? So Japan has the largest number of deployed robots, even though the number declined, presumably because of the rising of manufacturing industry and deployed robots in South Korea and China. Right? Now, not long after that, okay, in 5 years later, in year 2016, I mean, it turns out China was on an exponential growth curve, right? In year 2016, China overtook all the other countries and becomes a country with the largest number of deployed industrial robots. And that trend is still continuing. And in year 2019, China deployed an additional 140,000 robots. And that's more than all the other 4 countries added up together. Now, China today is not only a net consumer of robots, it's also increasingly becoming a powerhouse of new robot technologies. Right? If you're unsure about that, well, these days we can always ask Google. Right? So if you key in China robotics startups, that's what you would Google will tell us. This Chinese city is now the Silicon Valley of robot startups. They're talking about Dongguan in Guangzhou, not very far away from Hong Kong. And then there's the top 10 hottest robot startups from China, and SoftBank wants to make a major investment in Chinese robot startups, right? And also that you probably know about DJI and the drone company, right? So this Chinese robot startup, it's only a little bit more than 10 years old, including its stealth period. And it has 75% of the world's commercial drone market, right? But not all things can be compressed in time. Robotics requires hardcore technology development. We'll also find out that even though China is moving very fast, some of the hardcore technologies is still lagging behind the established players in Japan and Germany. But if it takes time to develop and catch up with technology for a country with lots of resources, right? Maybe you can just acquire them. So you can see that media completes the acquisition of German robot maker KUKA. KUKA is this company I mentioned to you earlier, Germany's most advanced robotics company. Right? It just got acquired by China 3 or 4 years ago. So China is a large, complex country, and the Chinese robotics company market is also large and complex, and all these things coexisting there. Now, looking into the future, so what can we do? What's to come? Speculating in the future is also is always a little bit dangerous, but I'll help make a little bit. I have a few observations to make over here. Right? So one thing we can, in terms of examining the robot technology, so we can look at the success of the potential success and risk of deploy robot technology. I think we can take a look at two main factors. One is environment variability. How much does the operating environment vary? The other one is human interactivity. How closely the robots must interact with human. Right? So on the lower left corner, if it is low variability and does not require much interaction, usually the technology much easier to deploy and become successful. Right? So it's no surprise that's exactly the strategy of manufacturing industry. Now, if in the future we want to deploy robots in let's say hospitals and for health and wellness sectors, the environment the environment variability, at least it's somewhat contained, but the requirement for interactivity with humans is very, very high, and that's hospital services, and some of the services requires direct contact with the humans, right? And so now if you compare with the service sector definitely exhibits greater environmental variability because it cannot be controlled at all. And but at least in some of the service sectors, I mean, we do not need to come directly into contact with humans. So if you compare these two, you can see that there is trade-off over here. Now, the other way to look at these things is to look at technology maturity and the benefit of successfully deploy a particular the technology. Now, here you can see that, for example, if we take a look at the transportation industry, right? So now in this chart over here, if you stand top right corner, means that the technology is relatively mature and the benefits is large, right? So then you stand out to the upper right. And that's somewhat what the transportation industry kind of autonomous self-drive lies, right? So the technology, I think that we are almost on the cusp of it, and it will be almost ready, even though there are still some hiccups. And transportation mobility is extremely important for all of us. And therefore, that's why the autonomous driving industry is so hot and attracts so much investment. Right? Now, if we want to think about hospital services, health and wellness, and then, of course, the benefits is enormous. Human health is extremely important, but unfortunately, that our technology is not yet quite there yet, and so there's lots of opportunities, but also a lot of challenges over there. Now, the hospital service robots is in fact an instance of a class of robots, which I would call a professional service, right? So in this class of, in these domains, usually there is substantial variability, but usually robots interact with professionals, and therefore that in those environments that the variability can be somewhat controlled, and the professionals through training can take care of the remaining variability. And so the chance, there's lots of opportunity over here, and it's to come, right? So that includes the hospital services, professional cleaning, construction, and the water exploration, firefighting, and so on and so forth. And one successful example of that, is actually autopilot. And some of you may not be aware that, in fact, the planes that we fly on, because of COVID, we don't fly that much anymore, but we used to fly on, it's actually a robot. And most of the time, and that these aircrafts actually flying by itself. But the pilots are trained professionals right? So this is, if we think of the autopilot for the flight control system as a robot, and then this is again basically a professional service robots. It does not directly interact with the passengers, but it is under the control of a professional like a pilot. So these sectors has enormous opportunities to come. So I think that I'm very confident that the robotics industry has a bright future ahead, and the demographic trend assures the demand, right? So the new technologies, AI and 5G, are driving forces of technology transformation in the short term. In a slightly longer term, that we need to understand human a lot better. And China is rising as a huge market for robots and a powerhouse, and increasingly a powerhouse of robotic technologies. And Singapore is in the immediate geographic neighborhood of China. We stand to benefit. Now, let me end by saying that all technology developments ultimately must serve the purpose of improving human conditions in order to be meaningful. And so we want to develop robots to help people by working with people together. And that is our destiny. And for myself, I would say that I'm hoping to get to the point of Hey Robots before my retirement, so that the Hey Robot will take care of me. And that's my end. Thank you for listening.
Thank you, David, for the great presentation. I have learned a lot from it. I find it very thought-provoking. Especially, I like the concept of trend of robots being very collaborative and then representing an effort to serve humans. And I was also quite amazed by the drastic development of the robot market in China. Maybe I'll have a question later about this. But for now, I will invite my colleague, Sharon, to take it from here to manage the Q&A session. Sharon?
Thank you. Thanks, David. That was actually a very interesting talk. I learned so much from what you have to share. Just a quick question, though, just to start off this Q&A. I mean, you presented a lot of different types of technologies in the robotics industries. Do you think, and going forward, the robotic industry will be one that is more fragmented, occupied by many little startups because you see so many companies doing it? Or do you think it'll be one that is dominated by a few big players? And are there some industry you think the deployment of robots just will not be accepted?
Right. So I think robotics is a very sophisticated technological field, and the robot industry is also very broad. So I think the safety answer would be they will coexist. But let me elaborate a little bit why that is so, right? So let's look at the spectrum, right? And robots, in fact, is a very sophisticated system with many components sorry. Yeah, so it seems that something happened on the network connection. Are we still connected?
Yes, we can still hear you. We can
hear you very well. Thank you.
I would say that to draw analogy, that the robots with the humans, robot must have the ability to be able to see, to be like with our eyes and be act with the hands and the feet, and also the brain that be connected, and all these components will be there. And therefore that there are a whole bunch of startups to focus on the components of the robot technology, right? And you can build a very sophisticated fast camera, or you can build a very sophisticated actuators and very powerful motors. So every piece of this component technology can form the basis of a startup companies, and they are all very important, each of the component, right? Now, you can go all the way to the other end, right, to the big players, and what companies like Google would bet. Or Google would bet that there will be a kind of a base platform that's a very capable robot. And once you have that becomes a reality, the rest is just software, right? I mean, just like once you have a base computer, you can write programs. You have the base robot platform. The rest of that is just writing software. And Google, of course, wants to bet on that because that they're good at this, right? Now, then there's things in between. Things in between are things, in fact, it's kind of interesting that has been happening all along, which is that you have some component technology, and then there's some needs over there. This component technology has to be assembled together in some customized manner in order to fit the need of the customer. It could be an assembly line, or could be some other tasks or medical device or whatever that thing. So that requires a system integrator with the expertise, be able to connect what's available technology and understand the needs of the customers and synthesize customize the system. This has been happening all along, and the ABB and many of the robotic companies do that, and for all along. Now, the excitement today actually happens at the two ends, right? Now, and the kind of in terms of the demonstrated success and the breakthroughs, and of course that the startup side has a lot more, and of course just because the difficulty of that Google's strategy requires integrated base platform that's adopted, and that is not a simple feat. That's why only large company with very deep pocket can possibly bet on that, right? So at one time, Google made a huge investment on a portfolio of robotic companies, I think maybe 10 years ago or something like that. And a few years back, then they sold the portfolio. And then, but then Google DeepMind got interested in, again, they started buying. Right, so I think that there's a lot of interesting developments over there. There's no single answer, but I think that there are a lot of interesting things to watch.
Okay, so I have a question because had something related to my field. I'm a finance guy, so I'm quite interested in how to finance the robot industry. Especially, you mentioned that we have many robot startups. A lot of money is actually flowing into the industry. So how would you comment on the current level of investment? Is it like over investment, that we are investing too much into this particular sector within really a short period of time, or is still under investment? So we still need more funds in general. And also, I'm doing research about innovation. We know that for industry like the robot industry, we really need companies to take long-term perspective because it takes really long time to see the economic benefits. But on the other hand, on the financing side, we do have many venture capital, private equity investors who are quite short-sighted. They focus more on the short-term return. Do you see this mismatch? Would this actually affect the future of the industry? So basically my question about the level of investment, also the mismatch, if there's any.
Okay, I think that there are many elements in your question. Let me start by saying that more money is always better, right? So I'm a robotics. Okay. If I say that the robotics industry has way too much money, I think my colleagues will all stare and scream and murder, right? So
okay, fair enough.
It's better. Having said that, let me go into a little bit of details. I think indeed that robotics, both as a technology and as an industry, is in a golden stage of growth because of the technology developments. There are significant industry interest from the investment community, and that is wonderful. And part of the reason is that I think it's really that at the cusp of technology transformation, right? So when I was a graduate student that working on robots, it's extremely painful, right? So when my robot breaks down and that gets to the level of circuit board and you're soldering things in order to fix my robots, and that cannot possibly be the basis of any real real world applications, right? So today that my students robots broken, okay, replace this camera, replace that board, replace this component and that. I mean, back in operation in a couple of hours' time, right? And now, and I think it's for these developments that there's a lot of interest and investment and propelling the field forward. Now, what you, but of course, as you correctly pointed out, that venture capital tends to have this short-term return kind of a psyche. Right, and that's why there's so much money that's pouring into autonomous driving. Right now, I wouldn't say that the technological issue of autonomous driving has been resolved. I would say that we clearly passed over the bottleneck. The remaining 5%, maybe 10%. Right, and it's still there, and we have to work out. Now, what prevents that from real-world large-scale deployment? It's not necessarily clear. It's entirely technological, right? I mean, when the car gets into an accident, who holds liable, and some of those issues. It's not clear that by investing in technology that necessarily will make the business necessarily immediately successful. This is one I would make. Another point is that long-term perspective for robot technology is extremely important. I would say that robotic technology is hardcore technology. All right, so I will give one example over here, which is that if you have seen that what our spot robot can do and what the big dog can do, and you can probably for a fraction of the price buy a robot from Unitree, which is a Chinese robot startup, and for a fraction of price, you can buy something that looks similar, okay, but it will do certain things, but not nearly the kind of things that I've showed you in the video. The gap between them is, I would say that, let me try to count, probably at least 25 years of hardcore research in the MIT robotics laboratory, another probably 20 years, 10, 20 years of technological development at the Boston. Right? It is that long in order to make a robot that's capable, reliable, and then we can trust the robots to perform and to deliver. And that's extremely important. And I hope that although I understand that the venture capital has its goals and so on, but do try to bear in mind that this long-term perspective and its huge long-term benefits as well. Okay. And I think that the investment community is, at least to an extent, aware of it, right? So the Boston Dynamics, this company, has been sold quite a number of times, right? So I think bought out by Google, sold to SoftBank, and sold to Hyundai, but Boston Dynamics has been there for 20 plus years. It hasn't really made money yet, but every time it gets sold, the value increases. Investors do understand its value, but we just need to keep that in mind.
Okay, I hope the company is not the exception. I hope this can apply to other firms as well. Yeah.
Yeah, we actually receive a lot of questions about the interaction between humans and robots. I think that's probably a major concern for a lot of either businessmen, consumers, or just in general people. And I think just now when we did the poll, 80% of the people wanted to interact with the human receptionist versus a robot receptionist. So I'm just going to sort of pick up a few questions that the participants have asked, okay? And we're going to unpack that a little bit. I think one of the questions that came out was that you mentioned that the robots in the movies are too far from reality. Now, do you think that one day the robots may potentially be self-aware with the development of AI? And how does this social robots, I mean, do you think that social robot will get more accepted by people in general now? I mean, you presented some that says, no, social robots up to now is still something that is not really that widely accepted or that mature. So what are your thoughts on that?
Okay. So let me venture a guess about why 80% of the people prefer a human receptionist rather than a robot receptionist. The answer is very simple. I think the robot receptionist not good enough. They don't do, they are not nearly as good as a human receptionist. Now, the question would be, again, we'll go back to this paradox. It seems that those simple things that we think that robots should be able to do, and therefore, but they are unable to do, right? And again, that I want to trace it back to this bias that when we assess robot technologies, that we tend to value those things that we can do overvalue those things that we cannot do ourselves, but undervalue those things that we somehow have difficulties for one reason or another, right? So let's not underestimate the ability of a receptionist. It has all the common things of a normal human being, and that is a lot. And the robot just doesn't have that ability yet, and therefore it doesn't get successful. And it's for that reason that we just hasn't passed over that threshold yet. Even though you can see that you mentioned about the social robotics and the social robotics companies, right? Why these perfectly good social robotics companies, and they come from very established laboratories. Some of the, I think, for example, Gbook come from MIT, right? They still had to flop. I think that it's just that what's needed in order to pass the consumer's threshold is not available yet in terms of technology, right? And also that I think the consumer technology, consumer market is also particularly demanding for robots because there's a price sensitivity over there. That's right. And also if you contrast with if you contrast that a little bit with, that's why I in my kind of speculation I mentioned professional service robot, right? Over there, like if you think about hospital, cost is no consideration. Every piece in hospital is so expensive. A $50,000 robot is no problem whatsoever. Right. So this trade-off between technology ability and the benefits it provides, as well as a cost, all of them together will decide the chance of adoption and the market success.
Yeah, good. So, but you mentioned about the so-called receptivity. So according to our poll, we have 20% are okay with robot as a receptionist. But this is reflect the people's attitude towards the whole thing. But you mentioned this is maybe because the robots nowadays are not good enough. But other than that, the maturity of the technology, will people's this attitude in the end will, stifle the development of the robot in long run?
Yeah.
So how can we change people's perception basically towards robots?
Yeah, thanks for mentioning that. In fact, I missed Sharon's last part of the question, which is this attitude thing. And I think that ultimately, I think my view is that we want to have robots that whose, let me for the moment call that values. If the robots can have conscious and values aligned with human values, right? But actually, I don't believe robots have values. Robots cannot have its own values. Whatever value it has, we give it to the robots, right, as design. So when we design our robots, we have to keep in mind our own values, right? So I think the interesting question over here is partly that in fact prompts ourselves as humans to understand our own values. And in fact, we have to articulate our values. And if we want to put it into, turn that into some kind of technology of engineering solution, in fact, we actually have to build models, quantitative models, in order to put that into robots. So we probably cannot directly align. I'm not, at least I don't directly foresee how we align what it means for robot values. But we can do is to build quantitative models of robot, important notions of human body values, for example, trust, and to build models and put that into robots, and as a result, generate robot behaviors that align with our values. And I think this is very important. Now, once we do that, I think the chance of the way that, and not only that we will create robots that exhibit behaviors that align with our values, but also that we would be able to explain to people that connects to this AI notion of interpretability and explainability, right? We can explain to people how these robot systems are actually built and why it would behave in the way that align our values. I think that would engender trust from humans in robots and encourage adoption.
Yes, and a couple of participants were also interested in this geopolitical differences. If you're still talking about China development, but still sort of behind the other more Western countries. So do you have any thoughts in terms of how far behind China's robotics technology is relative to countries in Europe and Japan, and specifically in what areas of the robotic technology you think they're behind?
Yeah.
Tough question. Tough crowd.
I think that China is moving very fast in terms of absorbing some of the latest robot technology and turn that into products and services. And on that aspect, I think that it's moving at an extraordinary speed, right? So I showed you this video about the Amazon's e-commerce warehouse. It's called Kiva System. It's actually a startup company that's acquired by Amazon. It's a Kiva System. I forgot exactly when was it, maybe 10 plus some years ago, right? But in no time that Alibaba recreated that system. And there's no direct comparison between the efficiency about these two systems, but it's safe to say that the Alibaba has a system that's almost as fast. It probably has at a larger scale, right? If you think about the volume of goods that's being shuffled around in China's logistics systems. So in terms of absorbing technology and maybe even improve it, to make it better, and for products and services, China is extremely fast. It's also inventing new technology. The best example I can give to you is about DJI technologies. But still, some of those things are hardcore, right? So, I mean, the materials, the sensors, and those things, and some of the fundamental principles. Right? I think that in those aspects, I think that China is still. I think it's very difficult to pin a number on them, but I think I would probably say that I can ask an analogous question now, which is that you can compare with asking the same questions about how long would it take for the universities in China to compete with the established universities in the US, in the Europe, in terms of the research capabilities to generate amazing breakthroughs. Right, so I will say this. Right, so I mean, this is not said by me, but it's said by a very famous Chinese scientist, Chen Shui. He asked this big question: how come in the last 50 years or even longer, China couldn't produce a single Nobel laureate. Why?
Very good question. I'm not sure there is an answer for
There's
this.
no answer, right? So I think that in order to have to leapfrog beyond I think this question has to be answered.
Yes. Mhm. Yeah. Good. I also have a related question related to the development of robot market in China. Given that we know China is a very populous country, so many people, and then at the same time, I think that we see a lot of industry robots being deployed, and you mentioned the rate is pretty high. So should we worry about this industry robots deployment will actually drive people out of work? Would that create any social issues, for example, in the country, such as unemployment? Would that be a concern for you?
You mean in China in particular?
Yeah.
Well, this at some moment it could be a problem, but I don't foresee that in the near future.
Mm-hmm.
The reason is the following. Number one, that I think a lot of those potential labor issues that's talked a lot in the Western media, I think it's a little bit exaggerated, and things are not that bad. Okay. Mm-hmm. And robot is not nearly as capable to replace even a receptionist. Let me put this. And the second, I think education plays a very important, education and training in general play an important role, right? And to this day, I think humans are far more adaptable than machines, than robots in particular. Right? If we humans are willing to receive, are open to the idea of education and training, and we can adapt ourselves, and that would partially address the problem. Now, another important thing is that actually this problem in the case of China may not happen at all. You guess why that the number of robots is sort of increasing on this exponential curve, right? I mean, actually, we have very specific reason for that. One is as you would expect, demography, right? The number of people, the number of young people available for work, right? Because of the population control measures, it's really
reducing.
It's because of that. China, it's not like China wants to put in a lot of robots, it's about China needs to put in a lot of robots, right? And the other reason is indirectly related to that demography, which is that if you look at the wages in China for the assembly line workers' wages, it's also going up like this. So it's really by need. It's not just it's real by necessity that the number of robots in China is increasing at an exponential rate.
It's mainly driven by the cost needs and also the availability of labor force, I guess. Okay.
There's also a question from one of the participants, which I thought is very apt, given that we are hosting this in a university. The participant asked, do you think the STEM education in Singapore is sufficient for us as a country to embrace robotics? I mean, you've been training the students in a lot of very technical skills. Do you think that is sufficient, or do we need a different set of training? What do we need, I guess, as a country moving to a smart nation to embrace that?
It's a fabulous question. I think that very often that I think about this, right? So I think that in terms of our robotics industry in Singapore, I think we are still relatively limited. Well, partially because of our market size, but there are other reasons that indeed has to do with education, right? Now, university is a collection of experts, right? And we pride ourselves in our expertise, we divide ourselves into business schools, engineering schools, computing schools, and this and that. And we sit in our own camp and talked to people similar to ourselves, right? Now think about the consequence of that on our education and the education of our students. They will become somewhat like that, right? And of course, the university education in China is also changing, right? And we have starting to have more general education. We have double degrees programs, so the students' knowledge base is expanding. But for the moment, okay, let me say a couple of things, right? So not to say that I said that in the future that maybe robot engineers need to understand humanities and human behaviors a lot more, but let's come to a much more narrow things, all right? There are two camps, even in the robotics community, engineering school itself, there are two camps. There are the computer nerds, and then there are the mechanical engineers, all right? They just keep on squabbling about which one is the real robots, real robotics people, okay? And this is no good for robotics and no good for the robotics industry. So it's very important, let's keep in mind. A robots has at least two parts, the body and the mind. We need both in order to work together. So a good education for a robotics engineer should have expertise in one of them, but very aware of the other as well, so that they can work together, right? So this one. Second, well, we become experts. So like I say that I work on sensing, I mean, like computer vision, be able to see the world, and then the mechanical, my colleagues in mechanical develop very capable, flexible, and adaptive actuators. We just do that thing. Well, at some point, someone has to put them together. Let's keep in mind, it's not enough to have a camera on its own, a motor on its own, or even a powerful computer that can kind of do all sorts of sophisticated reasoning alone. They have to connect together, right? A robot is a very complex system. I don't have a slide over here, but if I show you an architecture diagram of the robots, I mean, you can just see, you just see like basically what you see is like the tens or maybe hundreds of boxes over there, and with the wires connecting everywhere. Okay, so I mean, who has this ability to put things together, right? And where do you receive that education to gain this ability, right? So this is one place. This is one place. This one skill that is in general short everywhere, but particularly in shortage in Singapore. Right? There are very few people that, I mean, the system architects who have sufficient understanding of different parts of robot system in terms of technology, but also be able to understand the requirements of the particular domain and be able to put together the robot system, connect them to integrate into a working robot system. This is sorely lacking here in Singapore at this moment in time. So the national, Singapore has a national robotics program. And I talked to people over there. We are all very concerned that we are trying to develop the capabilities in Singapore, but this is a major challenge.
I'm really glad that you mentioned this, because we really need a holistic view of it, and we tend to see robot from a very technological perspective. And there's really this human piece, the mind piece, that's actually really important. That's a great answer. Thank you very much.
Yeah. So maybe this is the last question from me, given the time we have. So this is actually the first question from the audience. It's actually about how realistic and safe will it be to introduce autonomous flying drones to perform delivery tasks in a place like Singapore, high density city. And this is also related to our first poll question, how long it take for this door-to-door robot delivery service really cover nearly all Singapore. So what's your view on that, on these questions?
this question from mostly a technological standpoint, right? Whether it is possible, are we in reach within the striking range of technology that we will be able to use drones to deliver goods in a densely populated city in Singapore, right? I would say that kind of yes, right? And and in connection with the poll question, which is that it seems that many people are very optimistic. I saw something like 30% or even more that within 3 years. I think that's a little bit too optimistic.
45%, yeah.
Yeah, I think that's very, very optimistic. I think that I'm a little bit more pessimistic than that. So I think if you want, we need something like that. Essentially, within a 5-year horizon, basically that it requires a technological solution as well as some kind of business solution. Door to door requires that the robot to handle enormous amount of variability. All right. So if you think about the delivery task, normally we call it the first mile, last mile, and somewhere, and then the in between. In between, in fact, is the variability is relatively controlled. You are on the roads, yes, there are the vehicles, but all roads are kind of similar to a large substantial extent, right? So look at the roads in Singapore. Is that different from in China or in US? Not really, right? But the last stretch, or maybe the first stretch, can be very different. I mean, that you going to different buildings and be interacting with people and so on and so forth. Okay. So drone delivery, if you are talking about delivering to some kind of a station to a building or things like that. Now, that's normally when we talk about drone delivery, it doesn't fly through your window. Let me make it clear. Drone delivery, delivering some kind of station on a building. That, in fact, is the technology we are reasonably close to that. Okay. And in fact, that maybe they might as well. It may even help in terms of accelerate the progress of this robot delivery services. I mean, you can fly. I mean, Singapore on the roads are so congested. I think it's hard to believe that we can put lots of robots on the road, and the drone delivery may help. In fact, okay. But now. Back to the survey question, I intentionally made it kind of a vague and then said about door-to-door delivery. Now, if you want to deliver to the door, then it becomes a real technological challenge that will take more than 5 years, probably. I would guess that. But the problem is that we don't have to deliver to the door, right? So the way that in Singapore that our residents are organized, that the HDB blocks, and then there are the condominiums, so on and so forth. What we really need is probably deliver to some kind of collection point of some kind, right? Now, this is my question. I kind of cannot understand why is that. I mean, I understand in order to do something like it, it requires organization. Right, so let's say that the government takes the lead, and then let's say that okay, that we will have these collection points in the HDBs and the condominiums and so on and so forth, and then it becomes a base platform, and then on top of which and many robot delivery companies can operate. Right now, to establish this base platform requires a lot of organization, and maybe even there are some other legal issues and so on and so forth. Only government or very large organizations can take care of that. But on top of that, the technological solution that platform itself can enable all the technological solutions to that, right, and make it much easier and deployable. So my question is, why is that not happening? But that's not a technological question.
True.
Okay, I think given the time, this brings us to the end of this webinar. I mean, if you look at the conversation we have today, I mean, robots are becoming increasingly common in the society. And in the past, firms tend to use robot in the backend functions in the manufacturing setting. But now we are increasingly seeing the adoption of robots in the front end, people-facing situations. And I think some is clear, at least from the poll, that people are not entirely comfortable with the robot. From the questions we're getting, this is also clearly a main concern for companies and for a lot of us, I guess. But I think at the end of the day, a better understanding of the future development of the robotics industry, how we can utilize this technology in the way that people are comfortable is important. And David gave a fascinating presentation on what the future can potentially look like, what we need to get to there, and also a good overview of where the industry is moving. So we'd like to thank David for a very interesting and insightful talk. Now, this distinguished speaker event is part of the NBS Knowledge Series. So do join us for any future events. And thank you for joining us in this webinar, and have a good day.
Thank you. Thank you, everybody. Thank you, David.
Thank you.
Mm.